All right, welcome back. We are continuing to talk about ways that we can solve quadratic equations. Let's just do a quick review of the methods that we've seen so far. And the methods that we've seen so far have all been subcategories of what we call factoring. And there were three methods that we saw for factoring. And the first one was the X box method. The second example that we saw was the two-term factoring. And then the last example that we saw is just called the X method. Now let me give you an example of when you would use each of these three methods. So for the X box method, we use that when we have all three terms available and the a value is equal to something other than 1 or -1. So for example, if we had 3x squared minus 23x minus 36, if we were trying to factor that expression, then we would use the X box method. For two-term factoring, if we had something like 25x squared plus 5x, in that scenario, our c value is equal to 0. So that's when we would use two-term factoring. And then the X method is when we have all three terms, but our a value is equal to 1. So an example of that would be like x squared minus 8x minus 9. Okay, so that was just a quick recap of the factoring methods that we've seen so far. The next method that we're going to talk about is the square root method. So sometimes we can just take the square root of both sides of the equation. This is when you only see one instance of the variable that you are solving for. So notice here we only have an x squared term, but we don't have any other x's there. And so what we would do in this instance is we are starting off with 16x squared is equal to 11. I would divide both sides by 16. So I get x squared is equal to 11 over 16. And then I would take the square root of both sides. Now you want to be very careful. When you have an equation and you take the square root of both sides, you're going to end up with both a positive and a negative solution. Let me give you another quick example off to the side here. So like let's say we were trying to find all the values such that when you square it, it gives you the number 4. Now if you think about this, it's going to yield two solutions. There's going to be x equals 2 and also x equals -2 because both of those numbers squared gives you 4. And so how we solve that is we would take the square root of both sides, and so we would get x is equal to plus or minus the square root of 4, which is 2. Okay, so that's what that symbol means in front of the 2. We say plus or minus to indicate that it is both the positive and the negative value. Let's go back to example 4. So if I take the square root of both sides, we would get plus or minus, and then we would take the square root of both the denominator and the numerator. The square root of 11, 11's not a perfect square, so we could just leave it as the square root of 11. 16 is a perfect square. If we take the square root of 16, we get 4. So our two solutions are positive and negative square root of 11 over 4. Let's move on to example 5. Okay, so here, similarly to the last one, we can just take the square root of both sides. So we're starting off with x minus 4 squared is equal to 36. So I would take the square root of both sides, and the square root on the left side undoes the exponent. So we're just left with x minus 4, and then the square root of 36, since we're dealing with an equation, that would give us both positive 6 and negative 6. So I'm going to write that as two different equations. Okay, so now that I have two separate equations, I'm going to go ahead and solve both of them. So I'm going to add 4 on both sides here. So we get x is equal to 10 as one of our solutions. And then here I'm going to add 4 to both sides. And that will give us x is equal to -2. Go ahead and on your own verify that these are both, in fact, solutions. All right, so earlier in these set of videos, I said that standard form is really nice when we're trying to use something called the quadratic formula. And the quadratic formula, alongside factoring and the square root method, the quadratic formula is another method to solve quadratic equations. Now, the nice thing about the quadratic formula is that it always works. Factoring does not always work because sometimes the roots or the zeros or the solutions of the equation can get kind of messy or ugly, but the quadratic formula always works if there are solutions that exist. Sometimes there are non-real solutions, and don't worry about too much what that means because we're not going to talk about it so much in this class, but if you maybe take future math classes, you might get into that more there. But the nice thing, again, let me just reiterate, the nice thing about the quadratic formula is that it always works if your function is in standard form, and I should probably add, and it has real solutions. Again, sometimes quadratic equations don't have real solutions, so the quadratic formula will not work in those cases, but in all the other cases, the quadratic formula will always work. And so the quadratic formula states that if you have a quadratic function in standard form, then its roots or zeros are given by the formula x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Now I'm sure many of you have already seen this formula before. It's kind of like repeated over and over again in algebra classes, so you might have seen it in high school or maybe in an algebra class somewhere else. But when I learned this formula, my high school algebra teacher gave us a mnemonic device, and so I will just share with you verbally that mnemonic device, and it goes like this. It's kind of a story. It says, a negative boy couldn't decide whether or not he wanted to go to a radical party. He ended up being a square and not going, and so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. So that was the mnemonic story, mnemonic device that my algebra teacher told me, and I've always thought about that when using the quadratic formula. Anyways, so let's move down to example 6. It says solve the equation 2x squared minus 3x minus 7 is equal to 0. Okay, so we want to solve this equation, but a lot of times factoring is easier than using the quadratic formula. So why don't we try to see if we can factor this? Now notice our a term is 2, which means that if we could factor it, we would want to use the Xbox method. If we are able to factor it. So let's go ahead and make our x. So on the top portion of our x, we want to put our b value, which is -3. And then on the bottom portion of our x, we would put whatever a times c is. So 2 times -7 is -14. Again, so here we would put b, here we would put a times c, and we would want to find two numbers that add to b and multiply to a times c. Now, I don't know about you, but I cannot think of two whole numbers that add to -3 and multiply to -14, and that's because there are none if we're talking about whole numbers. Okay, so let's go ahead and erase that. And so this illustrates why we're not always able to use factoring methods. However, we are able to always use the quadratic formula. So our values are going to end up being x equals negative b, so our b value is negative 3, plus or minus the square root of negative 3 squared minus 4 times 2, and then our c value is negative 7. And that is all over 2 times our a value, which is 2. Now we do want to go ahead and simplify that. So negative 1 times negative 3 is positive 3. Negative 3 squared is 9. Let's see, 4 times 2 is 8. And then 8 times 7 is 56. And that's going to be a positive 56. And then the denominator we can simplify as 2 times 2, which is 4. So I'm going to write equals 3 plus or minus the square root of 9 plus 56 is 65 over 4. Now, 65 is not a perfect square, so we would just need to leave it as the square root of 65. So our final answers for that equation are x equals, and if you'd like to write it as two separate numbers, you can. So x equals 3 plus the square root of 65 divided by 4, and x equals 3 minus the square root of 65 over 4. In the future, I'm just going to write it as one fraction using the plus or minus notation, but please do note that it's actually two different answers. And really quickly, let's just estimate these numbers to get an idea of what they are. So I went ahead and I plugged those into my calculator, and the x values are approximately 2.7656, and the other one is approximately negative 1.2656. Okay, so those, I'm just going to box the fraction portion because the other ones are decimal approximations. So generally, I would like you to leave your solution as an exact form in the fraction.